Right now, Mercury is still shrinking. Its entire surface is buckling inward right now as you watch this, and NASA has no way to stop it, no way to even fully explain it. This isn't ancient history. It's happening today on a planet that's been quietly collapsing for billions of years. And what scientists found when they measured just how much it's lost is the part they don't like saying out loud. Mercury is the closest planet to the Sun, scorched, airless. Just 36 million miles from a star that could melt lead on its surface. For decades, we barely looked at it. Too hot, too close, too hard to reach. But when NASA's Messenger spacecraft finally mapped it in detail, it found something wrong. Cliffs. Enormous cliffs hundreds of miles long cutting across the surface like scars. Geologists call them lobate scarps. Translation, wrinkles. Wrinkles on a planet the size of our moon. And wrinkles only form one way. Something inside is shrinking and the surface is folding to keep up. Here's where it gets disturbing. Mercury has shrunk by at least 4.5 miles in radius. Not lost material, not eroded, compressed, squeezed from the inside like a grape drying into a raisin, except this raisin is a planet and it's still happening. New images show scarps so fresh, so uneroded that they had to have formed in the last 100 million years. On a cosmic clock, that's yesterday. Which means Mercury isn't done. It's still contracting, right now. And here's the problem. The obvious explanation, a cooling core slowly solidifying and pulling the planet inward, doesn't add up. Run the math on a cooling iron core and you get a shrinkage far smaller than what Messenger actually measured. The numbers don't close. Harvard researchers have run models. Caltech has run models. Nobody's model matches the scars. Something else is happening inside Mercury. Some process still active, still squeezing, and right now, nobody can name it. That's the part they don't advertise. The most studied rocky planet after Earth, and we can't explain why it's still crushing itself. So what if it's not just cooling? What if Mercury's core, proven to be enormous, more than 85% of the planet's total volume, unlike anything in the solar system, is doing something we've never observed in a planetary body before? Some researchers have floated a strange possibility that Mercury's core is only partially solidified, caught in a slow, uneven freeze, with solid iron crystals raining down through liquid metal like snow falling through a dark ocean. Each crystal that falls releases a tiny shift in pressure. Multiply that by billions of years and you get a planet quietly imploding, one microscopic collapse at a time. It sounds almost alive. It isn't. But the data doesn't rule it out either. And here's the strange part. It shouldn't be possible at all. A planet this small should have gone stone cold and solid ages ago. Mercury didn't get the memo. It's still active, still moving, still generating a magnetic field it has no right to have, given how small and dead a core its size should be. That magnetic field, weak but real, is itself a mystery tangled up in the shrinking. If the core were simply freezing solid the way every model predicts, that field should have flickered out long ago. It hasn't. Something is still stirring down there. Something with enough motion to generate a magnetic field and enough force to fold a planet's crust like paper. And that's what should worry us more than it does. Mercury is a preview. It's the fastest cooling terrestrial planet in the solar system, closer to the Sun, smaller, simpler than Earth. If its interior is still doing something we can't model correctly, then our understanding of every rocky planet, including this one, has a hole in it. Earth's core is next on that same slow, cooling timeline, just further behind. The physics we use to predict when planets go geologically dead, no volcanoes, no magnetic field, no protection, is built on assumptions Mercury is actively breaking. Every model of planetary death may need to be rewritten. And we're the ones who have to live inside the results of getting it wrong. So Mercury keeps shrinking. The scarps keep forming. And nobody at NASA, Harvard, or Caltech can tell you exactly when it will stop, or if it ever will. What is actually still moving inside that core, 500 million miles closer to the Sun than we are? Tell me what you think is down there.